Math 3, Unit 5, Section 3. Today we're talking about modified box and whisker plots. Okay, how many of you have learned 5-number summary before? Okay, I thought most of you had, but we're going to go ahead and talk through this. Okay, going backwards, if you read this sentence here, we've learned about standard deviation. Okay, and standard deviation is a great way to measure the distribution of data when the data is normally distributed. Okay, now if the data is skewed left or right, then the 5-number summary describes the data better. What does skewed left and skewed right mean? Well, it means that either like all your data is like everybody did really bad on something, or everyone did really good on something. Like all your scores tend to be in one area instead of kind of in the middle, okay? Which kind of is like your Unit 4 test, okay? It all tended to be on the low range versus the high range, okay? So, now your 5-number summary, I know this is going to be shocking to most of you, but it makes 5 numbers.
Wow. No way.
Yeah, pretty crazy. Okay, so one of the numbers is your minimum or your lowest value within the data set. One number is your maximum value or the highest number within the data set. The next number you normally find is your median. What does median mean? Very good. So this is the middle. Okay? After you have your median, Q1 is the median of the first half of numbers, and then Q3 is the median of the second half of your numbers. And I hear some of you saying, oh yeah, we have done this before, I remember this. So now how many of you have done 5-number summaries before? Outstanding. Okay, how many of you have seen box and whisker plots before? Good. So for the most part, you guys know how to do these. You use your 5-number summary for them. The difference is that with the modified box and whisker plot, we will be talking about outliers. Now, who remembers talking about outliers? Okay, good. Quite a few of you. That's awesome. So we're going to practice all of this, so I'm not going to talk about all of these definitions, but the box part has 50% of the data. The majority of your data comes within the box, okay? Your whiskers are the 25% on either side. And the most important thing, or one of the most important things I should say, is that you need to make sure to label your axis. So if you notice here, what we're talking about labeling your axis is where you're putting in like the numbers. So we know what those numbers represent, what those points represent when you put them into your box and whiskers. Okay, so we're going to go ahead and just start creating these to get our practice. Okay? Now we have a couple fill-ins before we actually do our practice, and I think because what you guys just told me, you should know what goes in this blank.
Outlier.
Very good. An outlier is a value that doesn't follow the pattern of the data values. Outliers could have a drastic effect on the mean and standard deviation. To determine whether or not an outlier exists, upper and lower boundaries are calculated. These boundaries are not necessarily elements within the data set. So just because you find these numbers doesn't mean they're actually going to be there, okay? The values are to help determine if outliers exist. When you're finding outliers, the first thing you have to do is find the interquartile range, which is the IQR. And how you find the IQR, your interquartile range, is you take Q3 minus Q1. So once you have those values, you separate them, or sorry, you subtract them. Okay. Once you have that value, to determine if any numbers in the data set are outliers, you determine the lower and upper boundaries as follows. So this is your lower boundary formula, and this is your upper boundary formula. Now, personally, I don't like you guys memorizing formulas. And I feel like if we do things enough, we just remember how to do things. We're not remembering a formula. And so you're not going to have to memorize these because we're just going to know how to do it. Okay? And we're going to go through that process here in a minute. All right, and this says blank are any numbers in the data set that are less than the lower boundary or greater than the upper boundary. Do you know what goes there? Outliers. Very good. Okay. The whiskers are then drawn to the highest and lowest values that are not outliers. So using outliers in your data will sometimes change your whiskers because you have outliers and you will not draw the whiskers to the outlier values. Okay? All right. So now we are going to practice all this. The first thing you always have to do is create your 5-number summary. Okay? When you are doing that, your data, we're using this data, you always need your data to be in order, okay, from least to greatest. So let's go ahead and make a note right here. Order data from least to greatest. Sometimes they'll already have it in the correct order for you, and sometimes they don't. Now, we could go through this and I could have you guys order them, but I know you guys know how to order numbers, so I'm just going to tell you how the order goes, okay? So, here goes the numbers. You have 1, and then I would put a comma between each number. Next, we have 10, 12, and then there's 3 15s. And then we have 2 16s. 17, 18, 19, 20, 21, 25, and 42. Whenever you're rewriting data, you always want to go back and make sure you have the same number of data values. So if you were to count up here how many numbers there are, there should be, or there is, I should say, 15 numbers. Okay? Once you have these in order, you want to number the data because this is going to help you with your 5-number summary. So I'm going to go back and I'm going to use a different color so it's easy to see the difference. And I'm just going to number this. So I should end up numbering up to 15. Okay? Okay, so based on this information, what is my minimum value? 1. What is my maximum value? 42. Very good. Okay, now when you are finding your median, there are different ways of finding the median, but sometimes you could have a list of data that's like 128, okay? And so the easiest way to find where your median is to take your total amount of numbers, which in this case is 15, and you divide by 2, which makes what? 7.5. And then you always round up to that next number. So in this case, my median is going to be the 8th number. Okay? And I'm going to show you this. So we're going to go here. We're going to circle our 8th number here. And if you count, there are 7 numbers on the left side, and there are 7 numbers on the right side. Had there been 16 numbers, okay, 16 divided by 2 is 8. But there's only 8, there would only be like 8 on each side. So if you ever are trying to find your median and you end up with the whole number, like let's say we just ended up with 8, the median is really between the numbers 8 and 9, and you would have to take the average of those 2 numbers. And we'll get practice doing that. So you're always going to round up or take the average of 2 numbers. Okay, are we okay here? Yes, and you could do it that way. But, so somebody was just saying, couldn't you just keep going in like this? And that, you could do that, but sometimes you will have data that's, like I said, 128 or 127 long, and you would not want to do that. That would take way too long.
Wait, so you always divide by 2?
Yes, divide by however many numbers you have, divide by 2, and then you always go to the round, like to the next number.
Oh.
And so the 8th number is my median.
Okay.
Yes, yes, because we're cutting the data in half, okay? So this is my median, and we're going to write that value, which is 16. Everybody okay there? Now, your median is not part of this half of data, okay? So this 8, it's almost like it's not in the problem right now, okay? And so now we have to find the median for Q1, because Q1 is the median of the left side. How many numbers are here right now? 7. So again, you could count in like how Casey was saying, we could count in and get our middle number. Actually, I think it's right there. But sometimes, again, our data is huge. And so I know there are 7 numbers on this side. So just like I did before, I would go 7 divided by 2, which is 3.5, and then we always go to that next number, which is 4. Okay, so this right here is my Q1 value, 15. And if you look, see how we have that median? There's 3 numbers on the left, and there are 3 numbers to the right of that. On this side, we just start here, and we have to count 4. 1, 2, 3, 4. That is my Q3 value. And again, you notice that you have 3 to the left of it here and 3 to the right of it. Okay, and we're going to write that for our value for Q3, which is 20. At this point, does anybody have any questions? Okay, so this is our 5-number summary. This will not change. This is what it is. But when we are doing our box and whisker plot, we have to check to see if there is outliers. Okay, so we first start by finding our IQR, our interquartile range. For notes, I'm going to go ahead and write the formula here for you. And we know for IQR, it is Q3 minus Q1. What is my Q3 value? 20. And 20 minus Q1, which is equals 5. So my IQR over here on the right, we're going to write is 5. Now, when you're going to find your lower boundary and your upper boundary, you always need to take your IQR value, which in this case is 5, and multiply it by 1.5. So in your calculators, because you get to use calculators, you go 5 times 1.5, and what do you get? Very good. Okay. So this value, the 7.5, we use this to find our upper boundary and our lower boundary. Okay? So, starting with my lower boundary, we will take our Q1 value and subtract 7.5. What is my Q1 value? 15. And 15 minus 7.5 equals 7.5. Very good. And so 7.5 is my lower boundary. Am I going too fast? Okay, upper boundary. We take our Q3 value and you add 7.5. And so in this case, Q3 is 20, and 20 plus 7.5 equals 27.5. So that is my upper boundary. Once you have this, we now go back to our data set. We are going to look, are there any numbers that are smaller than 7.5? Yes, 1. 1 is smaller than 7.5. And so that is an outlier. Are there any numbers greater than 27.5? 42. And so 42 is also an outlier. Okay. Any questions so far? Okay, so now we're going to create our box and whisker plot. Okay. The first thing you always need to do is label your axis. And if you go and count, I know I need to get from 1 to 42 or like 1 to 50. And so if you count by fives, this I would start at 0. And I go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So that would work by counting by fives. You could also count by tens. You could count by twos. So whatever makes the most sense for the data you have, that's how you want to label your graph. Does that make sense? Okay, so 0, I'm going to do this by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And like I said, it's very important that you label your axis. Okay? Now, when you're creating your box and whisker plot, there's all these lines here. It doesn't matter where you put it. You just want to keep them all on the same line. I'm going to end up going up to like the 3rd line when I'm marking stuff. Okay? So, the first thing though I'm going to mark are my outliers. And those we are just going to put as an X because they're not going to be included in the box and whisker parts. Okay, but it's still part of my picture. So here is 1. So I'm going to actually 1, 2, 3, 4. You could do little tick marks if you want to. So 1, I'm going to go up to the 3rd line and I'm going to put an X here because that is an outlier. And for this graph, you might want to just label what everything is so that you know what it is when you look back at it. Okay, there's also an outlier at 42. So again, I'm going to go to 42 and go up to like the 3rd line, and I will also label that as an outlier. Now, if you look at your min and max values, those are outliers, which means that your lowest and highest value now is the number next to the outlier. So that means that my highest value on the graph when I'm doing my box and whiskers is actually going to be what? 25. And then my lowest number on my box and whiskers is now going to actually be 10. So you might have to come back to this, but you don't change that in your 5-number summary. That is still your 5-number summary. It's just on your box and whisker plot, because there were outliers, these now become your new low and your new high. Okay, so I'm going to go ahead and mark my low, which is at 10. Okay, so I'm going to go up to the 3rd line and mark a 10. And if you want to, you could put lowest value without outliers. Okay, the next one we're going to mark is our Q1, and what is my Q1 value? What is my Q1 value? 15. Okay, so we're going to put a point at 15, and you always connect your lowest value to Q1. Okay, and we can go ahead and mark that as Q1. Next, we're going to mark our median, which is what? 16. Good. So 16, we're going to put a point right there. I'm not going to connect anything there right now. And then Q3 is what? 20. So we're going to make a mark at 20. I'm going to label that as Q3. I forgot to mark this one as median. And then we're going to mark our highest without the outlier is what? 25. So again, we'll do highest number without outliers. Okay, and you always connect Q3 and your highest number. Your box always goes around Q1 to Q3. So notice how I'm going to kind of re-highlight some of this so we can see it. This is the box from Q1 to Q3. These are the whiskers. And then you normally draw a line here where your median is. So what this is saying is that most of your data is in the box. 50% of your data is in the box, okay? And on this side, there's 25% on this half of the box and 25% of your data on this side of the box, okay? And then your whiskers also represent 25% each. Does anybody have questions on this box and whiskers? We're okay? Does anybody need more time with it? All right, we're gonna go ahead and try the next one. Are you guys ready? Okay. So looking at this data, what do you notice? It's already in order. Very nice. And we have to label our data and number it anyways, so we can number it and figure out how many pieces of data are here. So we're gonna go ahead and start with 1 and number these. Okay, so we have 16 pieces of data, and looking at this, we automatically know what two values. Our minimum, and what's our minimum? 3. And what is our maximum? 47. So when you're creating a 5-number summary, we should definitely not get these wrong, okay? All right. Now, there are 16 pieces of data, and who remembers what we do in order to find our median? Good. So 16 divided by 2 makes 8. Since this is a whole number, it is between 8 and 9. And you will need to, I'm going to put, take the average. So the median is going to be between 8 and 9. Notice I'm not circling either of those numbers because it's in between those values and we're not taking any of those numbers out of the data. Where before, when the median was a middle value, it was like it was the median and it wasn't included in any other data sets. Okay, so what is 12 plus 15? 27. And 27 divided by 2? 13.5. So my median is right here. It is 13.5. Okay, how do I find Q1 now? How many numbers are on this side of the data? 8. And so just like we did before, we go 8 divided by 2, which is 4, but because it's a whole number, that means we're going to go between 4 and 5. And so this is where Q1 is. And if you take the average of 6 and 6, you end up getting 6. So Q1 is 6. And then same thing on this side, there are 8. So we count 1, 2, 3, 4, and we know that Q3 is in between 12 and 13. And if we take the average of these, we end up getting what?
21.
It's still going to be what? 21. Oh my goodness. Okay. So Q3 is 21. Are there any questions about what we just did there? Okay, so now we're going to find the IQR. Who remembers how to find IQR? Good. So again, if you want to write it down, Q3 minus Q1. So in this case, we will take Q3 is minus equals 15. And before I can find the lower boundary and upper boundary, what do I have to do with my IQR?
Multiply by 1 point.
Very good. So 15 times 1.5 equals 22.5. Okay, and so when you're finding your lower boundary, what do we do? Good. Q1, which is 6, minus my value here, which is 22.5, and that equals what?
16.5.
Negative 16.5. So my lower boundary is negative 16.5. My upper boundary, what do I do? Q3, which is 21, plus 22.5. And what does that equal? 43.5. Okay, so now that we have these values, we go back to our original data set and check for outliers. So I'm going to move this down here a little bit so we can look back at our data. And do we see any values that are less than negative 16.5? No. Do we see any values that are greater than 43.5? So 47. 47 is an outlier. Which tells us, too, that what is going to be my highest number on my box and whisker now? 32. Is everybody good with that? Okay, so you guys ready to create this? Okay, so my minimum value. Oh, first, what do we always have to do? Number them. And this one also goes to about 50, so we're going to go by 5s again. Okay? So 0, 5, 10, and so on. So lower is anything smaller than that value is an outlier, and upper is anything bigger than that value. I don't understand. Do you agree? So the lower boundary is 7.5. So meaning that anything that is smaller than this value is an outlier.
Oh, so
There was nothing lower. There was nothing. If you had a negative 18, then it would have been an outlier. And so this one, the upper boundary is about 43.5. So anything that's above 43.5. Okay, so does anybody have any questions? Does everybody understand lower boundary and upper boundary and what that means? Is there anybody that doesn't get it right now? Please tell me, because
on the last one, how did you get 25 on the last ones that we did? The one before that.
The one before that. Okay, how to get what?
The whisker thing.
Okay.
How did you get 25?
Okay, so once you determine, and this is why I highlighted these values were outliers. The reason why they were outliers is because on the lower side, anything that is smaller than 7.5 is an outlier. So 1 is smaller than 7.5. Okay?
Oh, yeah.
Anything that is bigger than 27.5 is an outlier. So that's why 42 is an outlier, because it's bigger than 27.5. Once you have those outliers, so I highlight them so I remember, okay, those are outliers. You pick the next largest number, or the, you know what I mean? Sorry, the next smallest on this side, the next biggest on this one, to give you your lowest and highest. Okay? So back to this example, there wasn't any number that was smaller than negative 16.5. So this is still my lowest value is 3. But there was an outlier here, which is why I ended up underlining 32, because on my box and whiskers, that's going to end up being my highest value for the box and whiskers. Is that better?
Yeah, that makes sense.
Okay, so we're going to go ahead and start with our minimum. And so my minimum value is at 3. So we go up to 3, and we're going to make a point. I'm going to go to the second line this time. It doesn't matter what line you do. You just want to do the same line across. Okay? Sorry, I'll put this up a little higher. Okay, so next we are going to mark our Q1 value, which is at 6. So we'll make a mark here. And remember that you always connect your lowest value with your Q1. That's one of my whiskers. So I did my lowest and my Q1. And again, if you want to label these, you can. So this is going to be lowest. This is Q1. Okay, next we're going to put our median. And our median is at what? 13.5. So 13.5 is about right here. And we don't connect these. This is where my box is going to end up being. Okay, and then next I'm going to do Q3, which is 21. So I'm going to make a point there. And then my highest value is going to be not the max, but the next highest, which is 32. And so I'm going to make a point there at 32, and I'm going to connect that. And then we could have done the outliers at any point, but you need to make sure you mark your outliers with an X. So at 47, I'm going to put an X there for my outlier.
So if you don't have an outlier, then you just don't have one.
Exactly. Then you wouldn't have an X on your graph, and you just have your highest and lowest and all that. And then we're going to make a box around our Q1 and our Q3 values. And I forgot to label these. Sorry for those of you that want that labeled. So that's Q3, and that is my highest, if I could spell it right, highest without outlier or outliers. And then we also normally put a line here through our median. And that is our median, sorry. And just in case, I'm going to go ahead and highlight my box and whiskers for you so you can see it a little better.
Oh, I see.
Okay, questions?
What are those 2 lines that
Oh, I was just you know what, I meant to count like this, 1, 2. I meant to do my tack marks on the axis, but I didn't, and then I just made it wrong. So, yeah, 1, 2, 3, 4. Okay?
no, like
This right here?
yeah.
I just said I meant to mark those here, and I accidentally marked them there. So again, I meant to put these marks here, but I accidentally put them there. I'm sorry. Okay. All right. Any other questions right now on the box and whiskers? Hopefully we don't have our cell phones out right now. Okay. So this question says, so I want you to think about it before we say the answer out loud. If the outlier were removed from the data set, how would this affect the mean? So how would it affect the mean of your data set? So I heard some of you say the mean would oh my goodness, I can't write. The mean would what? Decrease. Because why?
Because you're taking on it, and then so
You're taking out the highest.
You're taking out your highest number, exactly. So because, and I just wrote the larger value would not be added, or you could put the highest value would not be added. Okay. The next question says, if the outlier were removed from the data set, how would this affect the standard deviation? And why? So remember that standard deviation is talking about what?
The average.
The distance, the average distance between numbers. And so if you didn't have that big high one, what's it going to do with the average distance between
Gonna
numbers?
decrease.
Exactly. So I'm going to write the, and instead of writing standard deviation, because that's so long, I'm going to use the symbol, okay? The standard deviation would decrease because the data would be less spread out. Or you could have even been more specific and like the distance between the numbers would be decreased, but something like that effect is great. Okay, any questions about that? Okay. So, last couple examples. The nice thing about this data set is that they've already given you your 5-number summary. Okay? Important information, though, that they've given here is that they're telling you that the class size is 38. Okay? So that means what? That means that if you were to have a list of all the numbers, there would be 38 pieces of data. Did I spell pieces right?
Pretty
Okay.
sure.
All right. So the question A says, do any outliers exist in the class? How do we find that out?
Oh, we can just do this.
We need to do the IQR. Okay? So we have to find out. There's mathematically a way to check. So IQR, remember, is Q3 minus Q1. So in this case, we are going to take 82 minus 68, which is 14. What do we do with that value now? Good. We take 14 times 1.5, which equals 21 is correct. What do we do with this number 21? Very good. We find our lower boundary by taking 68 minus 21, which is what? 47. And our upper boundary, we would do what? Say that again. So we would take 82 plus 21, and we get 103. Okay. Do we have a question? So remember your lower boundary, you always take Q1 and subtract that value. And your upper boundary, you take Q3 and you add that same value. Okay? So, right now we have proved our answer, but we haven't stated our answer. Okay? Do any outliers exist? Okay, in your groups, talk about it. Talk about your lower boundary and your upper boundary. So, if you think there are outliers, raise your hand. If you think yes, there's outliers, raise your hand. Okay, those of you that have your hands raised are correct. Okay? Lower boundary is 47. That means that any numbers less than 47 would be an outlier. Do you see here how you have 41? Oh, thank you. 41 is smaller than 47. So that means there would be an outlier. Now, if you're looking at your upper boundary, the highest value is 98. Is there any outliers on the upper bound? No, because 98 is the highest value and 103, you wouldn't have any values, okay? But, so for writing purposes, I'm going to write this out. Yes, comma, Outliers exist because I'm going to put LB for lower boundary, is 47, and the lowest value is 41. And all this other stuff proves our answer. Okay. Do you want to ask me any questions? All right. The next question says, B, does the value 75 need to be an actual data value in the original set of test scores? Explain your answer. So when we go and look, 75 is the median. Now, do you recall, if we go backwards to our previous, this median for this problem was not an actual number in my data set. Okay? But on this one, it was an actual number. My median was an actual number in my data set. Okay? So on this one, when we found the median, see how we got 7.5? We divided our number of data sets by 2. We got 7.5, and so we knew it was going to be the 8th number. Okay? On this one, when I was trying to find the median, I took the amount of numbers I had, which is 16. I divided by 2, and I got 8, which meant the number was going to be between 8 and 9, which was not an actual number in my data set. So, what will we do here in order to figure out if the median is in my actual data set? You would take 38 and divide it by 2. And I got 38 because that's how many pieces of data I have, correct? And 38 divided by 2 is what? 19, which means that the median is going to be between what?
19 and 20.
See? Between 19 and 20, which means, is this going to be an actual data set value? No. So we're going to write that out now. We have proved it. Now we're going to explain it, okay? So I'm going to put no, 75 does not need to be an actual data value because the median is the average of numbers 19 and 20 in the data set. Does that make sense? So Casey made a general rule, okay? And so those of you that did not hear her, she said, so basically, if this is an even number, it's not going to be a part of the data set. But if it's an odd number, it will be part of the data set. Does that kind of make sense? Okay. Last one. Are you guys ready?
Yeah.
Okay. Suppose a snack bar currently sells, it sells 384 distinct items, that cost between 25 cents and $1.50. They now decide to sell an item that costs $10. Select whether the value of each statistic for the prices of the items at the snack bar increases, decreases, or cannot be determined. So they're adding in, would you think this $10 would be an outlier? Yeah, because you would have all these numbers between 25 cents to $1.50, and then all of a sudden this one that's $10. Okay, so based on putting that $10 one in, what's going to happen to the median? It's going to increase. What is going to happen to the median? Cannot be determined. And the reason why we cannot determine the median is we don't know like where all these numbers are. We don't know all 384 items. Okay? Do you guys remember what the mode is?
Kind of.
It's the one that shows up the most. It's really can't be determined, but honestly, basically, it won't change. And let me explain this to you. The mode won't change because we're adding in 110. So all these other numbers, whatever the mode is, it's going to stay the same because the only thing we're adding in is a $10 price. Okay, but we're going to just mark cannot be determined because I didn't have won't change as an option. Okay, and then standard deviation, what do you think?
Increase.
It's going to increase. Okay, the spread of numbers is going to change based on you having that one that changed it dramatically. Okay, any questions?
No,